Okay, greatest common factor, section 4.2. If I have the numbers 8 and 12 and I want to list the factors of them, that's what goes into these numbers. So the numbers that go into 8 are 1 and 8, 2 and 4, and that's it. 1, 2, 4, and 8 are my factors. Now 12 is going to have a few more, 1 and 12, 2 and 6, and 3 and 4. So obviously the higher the number, the more factors you're going to have. Now our common factors are the things that they both have in common. What are the common factors of 8 and 12? Well, they both have 1s. They both have a 2 goes into them. They both have 4, and that's it. So our common factors are 1, 2, and 4. Now what is the greatest common factor, the GCF? What's the largest one? The largest one is 4. So of these two numbers, 8 and 12, my GCF is 4. And the reason you need to know this is important not only for this lesson, but later when you go to factor things out, when you're doing algebra and all the way up, you're going to need to factor. You need to find the greatest common factor so you can factor values out. Okay? Now, the last term here is relatively prime. This has to do with two numbers, as we're looking at here, 8 and 12. And this is when the GCF of two numbers is 1. So let me give you an example, and we'll look at it more later. If I have the numbers, let's say 8 and 15. Neither of these are prime numbers. 8, as we see here, has factors 1, 2, 4, and 8. 15 has factors 1, 3, 5, 15. But the GCF, the largest number that goes into both of them, is only 1. So the GCF is 1. So together, they are prime because there's nothing that goes into both of these numbers. And we're going to talk more about that in a moment. All right, example 1, find the greatest common factor of these numbers. Now there's two ways. One way is to list out the factors as we did above, 12 and 30. So I could do 1, 12, 2, 6, 3, 4. And by doing it that way, I meet in the middle and don't miss any. For 30, 1, 30, 2, 15, 3, 10, and 5 and 6. So my greatest common factor, the largest thing they both have in common, they both have a 1, they both have 2, they both have 3, they both have a 6, and that's it. My GCF is 6. Okay? Now the other method that I would recommend that takes a little bit less time, unless you only have like small numbers, is Euclid's method. Okay? And in class we talk about who Euclid is. Oops, Euclid's method. And what you do is you're going to take your two numbers, 12 and 30. And this is somewhat known as synthetic division, inverted division, different names. It takes on different roles. It's not exactly synthetic, but it's similar. So I want to see what goes into 12 and 30. Well, I could say, well, I know that 2 goes into 12 and 30. 2 goes into 12 6 times. 2 goes into 30 15 times. Is there anything that goes into both of these? Yep, there is. 3 goes into both of them. 3 goes into 6 twice. 3 goes into 15 5 times. Is there anything that goes into both of these? Nope, we're done. So that means I multiply this side, 2 times 3, and I get 6. And that's the same answer I got up here. Okay? This is also going to work for 3 digits. Okay, so if you have 3 numbers you're using, the same thing will work. I'm going to practice these ones down here using Euclid's method. So 21 and 42. I'm going to say what goes into both of them. Well, 7 does. 7 goes into 21 3 times. 7 goes into 42 6 times. Then what goes into 3 and 6? 3. 3 goes into 3 once. 3 goes into 6 twice. I'm done because nothing goes into both of those, so I'm going to circle and multiply 7 times 3, I get 21. So my GCF is equal to 21. Now here I have 27, 45, and 90. You want to make sure you know what goes into all 3 of these, and 3 does. 3 goes into 27 9 times, 45 15 times, and 90 30 times. Then I could go again. 3 goes into each of these. 3 goes into 9 3 times, 15 5 times, 30 10 times. I've got to the bottom. There's nothing that goes into all of these other than 1. So that means these 3 are relatively prime, and we're done. So I multiply whatever I have on the left. 3 times 3, I get 9. So my GCF is 9. Okay, let's look at the next page. Now the top part here says 2 or more numbers are relatively prime if their greatest common factor is 1. So if their GCF is 1, they're relatively prime, which we already talked about, okay? So in example 2, it says find the greatest common factor of these numbers and tell whether the numbers are relatively prime. I'm going to skip over these. If you'd like to see them done, really all they want you to do is go ahead and, you could use Euclid's method, 1833, what goes into both of these? I guess I'm not skipping over them too much, am I? Your GCF here is 3. That's sloppy, I'm sorry. GCF is 3. Are these relatively prime? No, not relatively prime. And I'm going to abbreviate because just for time's sake. But that's how you would do A, B, and then example 2, you try A and B. But let's take a look here at find the greatest common factors of monomials. So you're going to start out using the numbers like we have been, okay? And you're going to find your GCF, just the number part of it. Now for the variables, you're going to write them out. So this would just be x, this would be x. Since they both are in common, they both have one x, so we add an x down. So let's try the next one so you can see more of this circling method. I'm going to do 32 and 6. What goes into both of these? 2 does. 2 goes into 32, and I might need to divide a little. Whoops, 2. 16 times. And 2 goes into 6 3 times. Now that's the end, so my GCF, the numerical part is just 2, but now we have to do the variable part. So y squared is y times y, x squared is x times y, x squared y. So I look and see what's in common. What can I circle? Well, I have a pair of y's. If I have a pair of them, I write it down. And these are all extra, so I just don't count those. Those are extra, and my GCF is 2y. All right, we have one more page, and we're all done. Let's practice these ones. 20x squared, 36x. So I'm going to go ahead, find my GCF of 20 and 36. I can say that 4 goes into both of these, 5 and 9. So my GCF is 4. And this is x squared, so that's x times x. This is just x. So I have a pair of x's that gets tagged on. I'm going to skip this one and go down to r, just so we can practice more of the monomials. rs cubed is r times s times s times s. S cubed t is s times s times s times t. And r squared st squared is r times s times t. Now what do they all have in common? Well, they do not all have an r, but they do all have an s. So I can write that down. They do not have any extra s's, and they don't all have t's. So my GCF is just s. Alrighty. Last one. A choir director wants to divide a choir into smaller groups. The choir has 24 sopranos, 60 altos, and 36 tenors. Each group will have the same number of each type of voice. What's the greatest number of groups that can be formed? So let's do that. 24, 60, 36. What goes into all of these? 6 does. 4, 10, and 6. Then I can go again. 2 goes into all of these. 2, 5, and 3. And that's it. So my GCF is going to be 12. Now they ask the second part, how many groups are there going to be? There's going to be 12 groups. And how many sopranos, altos, and tenors will be in each group? Well, the first group was sopranos, so there's going to be 2 sopranos, it says here. And that's because 12 goes into 24 twice. There's going to be 5 altos, that's right here. 12 goes into 60 5 times. And then lastly, it's tenors. There's going to be 3 tenors. Okay, because there's 36 total. We're splitting them into 12 groups. 12 goes into 36 3 times. So you would write this out a little bit nicer, a nice word problem format, and you're good to go. Thanks, guys.